Good morning, boys and girls, and welcome to math class. So let's turn in our Go Math book. We are on 11.7 and we're on page 663. All right, so we did a review yesterday, the mid-chapter review on area and perimeter. So we're going to continue on with area today. Okay, so here we go. So it says problem solving, area of rectangles. How can you use the strategy find a pattern to solve the area problem? Judith just came to say hi. Hey, Jude. She sees the mailman. So it's going to get loud in a second. All right. Oh, there you go. She loves the mailman. All right, let's get back to math. Okay. So here's what we're going to do. We are going to look at finding a pattern. So we've been talking about patterns all year. So when I'm reading this story, I want you to look at these pictures as I'm reading and see if you can see a pattern taking shape, okay? All right, it says Mr. Coy wants to build storage buildings, so he drew plans for the buildings. He wants to know how the area of the buildings are related. How does the area change from building A to the area of building B? So if you look at building A and then look at building B, see if you can visually, just not by using a pencil yet, just visually see a pattern there. How does the area change from the area of building C, which is down below, to the area of building D? So we're not using a pencil yet. We're just visually looking at it and see if we can visually see something, the space that's changing, because we know area is the space that's covered, okay? So these are buildings, and so this would be like the floor that you're looking at, okay? Like the bird's eye view looking down. All right, so first off, use the graphic organizers to help you solve the problem, okay? So let's go down and read what they have written already for us. And I'll move my face off for a minute. Okay, so it says, what do we need to find? And it says, I need to find how the area will change from A to B and from C. Let's see if I can get this. Okay, so it says I need to find how the areas will change from A to B and from C to D. It also says, what information do I need to use? Well, I need to use the length and the width of each building to find its area. I will record the areas in the table and I will look for the pattern and see how the areas actually change. All right, so if you're looking at your picture, you have building A is 3 feet. Okay, so you guys are looking at your book and I'm looking at my book so that we can see. And we have building A is 3 feet, but the length is 4 feet. Okay, and so we know that length times width gives us the area. So we're going to say 3 times 4 is 12. Now, hopefully you guys are writing square feet because we are doing area. I don't have enough room because I'm using my finger, and so it's a thicker writing tool, so I need you guys to write down square feet. Building B is still 3 feet wide. It's exactly the same. But if you look at it, and I'm just going to scroll up here and get my head over to the other side. If you look, you'll see that this is 3 feet and this is 3 feet. So the width does not change, but the length does. But it doesn't just change to some random number. It changes to a double of 4, which is 8. So if you look at it, if you go straight down, you should be able to see that this right here, you can see 2 of those on the other side. So you're going to notice that it's still 3 feet for B, but it's 8 across, which is a double of 4. So you should be able to see that 3 times 8 is going to be a double of 3 times 4, which is 12. What's a double of 12? 24. What's 3 groups of 8 instead of 4? 24, because it's a doubles. And we've seen all kinds of patterns with doubles when we were first learning multiplication. We looked at that. Okay, so let's go to building C and D. Let's look at the length. Okay, so we have the length, which is going up here. We have the length here, which is 6, and we have the length here, which is 6, which is what of this? You are right, it is the double of the 3. Okay, so we have 6 feet down, 6 feet down. So we know that area is length times width. So the first one was 6 times 4, the smaller one. So 6 times 4 is 24. So think to yourself, okay, well, this is still double each other. Okay? So if it's double each other, what is double 24? Well, 4 plus 4 is 8, and 2 plus 2 is 4. But we know 6 and 8 went on a date in 1948. You are correct. So I see that the lengths will be the same and the widths will be doubled. The areas will change from, so hopefully you see they're changing from 12 feet to 24 feet, which is right here, and from 24 feet to 48, which is right here. So the lengths are the same and the widths are doubled. The areas will be doubled. I'm so sorry, it's messy. Okay, so we're going to go to our next page. We're going to try another problem. Okay. Okay, so hopefully you turn the page and you are on page 664, and it says Mr. Coy is building more storage buildings. He wants to know how the area of the buildings are related. How does the area change from area of building E to the area of building F? So please just visually look at E and F. Could you take F and stick it 2 times on E? So if you can visually see that without doing anything to it, that is wonderful. Okay, and how does the area change from the area of building G? So if you look at G and the area of H. So we want to look at the smaller one and see how many times could we put the smaller one on top of the bigger one. So what information do I need to use? So hopefully you have your book out and you're looking at it and you're thinking, I need to find the areas and how they're going to change from one to the other. And then also, what information do I need to use? Well, you definitely need to use the length and the width of each building. And then how will I use the information? Well, you're going to record the areas, and then hopefully you're going to use multiplication and looking at the pattern to see how it changes. Okay? All right. So you guys are going to be looking at your buildings. Okay? And so building E is 5 feet. Let's see if I can get it to write for me. Hopefully you're writing 5 feet. And the width is 8. And so we know that we're doing area, so it's length times width. So 5 times 8 is 40. Now this is why I keep telling you to practice your multiplication, because it's going to come up all the time, okay? So you are multiplying 5 times 8, and that's 40. You're writing square feet though. Remember, you're writing that down. Now building F has the same length, but it has double, or I'm sorry, the 8 is double the 4. So this is half of it. Remember, F is smaller, and so we know it is 20 square feet. So we know that 20 is double, and then you would get 40. Building G and H. So building G has 10 feet, and then it has 8 feet. So you're doing 10 times something. 10 times 8 is, you are correct, 80 square feet. And then we have for H, it is also 10. That stays the same. But the width is only half of the 8. It's 4. So it's 1/2 of 80. So 4 times 10 is 40 square feet. So if you're seeing the problem and you're seeing a pattern there, that's wonderful. You are able to see that if you change the width and you just double it, then the answer is also going to be doubled. So we went from 4 to 8, which went from 20 to 40. We went from 4 to 8, which took us from 40 to 80, which is doubled. All right, we're going to keep on going. And it says share and show. We're going to skip the share and show because my laptop, it doesn't like to work all the time. So if I can get it to work, I'll tag it on to the end of the video. Okay, so we're going to look at many pools come in rectangular shapes. How do the areas of swimming pools change when the widths change? So we're going to see a pattern, okay? That's what we're looking for is patterns today. First, complete the table by finding the area of each pool. So pool A has a length of 8 and a width of 20. Okay, well, first of all, we see that 20 ends with a 0. And anything times 0 is place value holder. You are correct, 0. So we know that placeholder value of 0 is 0. Now, we did the 8 times the 0, okay? So now we have to do 8 times 2. So that's going to be, you are correct, 16. So put a place value holder 0 to hold the ones place the whole way down, okay? Because we learned about multiplication. We multiply the first ones and then we do it to the tens. Well, we can see every single thing that we multiply in the ones place is going to end up being a big fat juicy 0. Okay, so we're going to use our place value holder 0. So then we're going to multiply 8 times 3. So we're skip counting by 8. Does everybody see that pattern? Because it's 8 times 2, 8 times 3, 8 times 4, and 8 times 5. So we are skip counting by 8s. But we have a place value holder of 0. Okay? So it's actually we're skip counting by 80. So it would be 80 plus 80 is 160, plus 80 is 240, plus 80 is 320, plus 80 is 400. Okay? All right, so let's see here. We've got, where am I? Okay, so we did the first part. First, complete the table by finding the areas. Okay. So then find a pattern of how the lengths change and how the widths change. So hopefully you're seeing, you can find the area by multiplying the length and the widths. The length stays the same, but the widths increase by, the length stays the same. And if you go to the width, it goes from 20 to 30 to 40 to 50. So the widths are increasing by, you are correct, 10 feet. Okay, so describe the pattern of how the area changes. So it says the areas are, what are they increasing by? They increase by how much? You are correct. It goes from 160 to 240, which is 80. From 240 to 320, it increases by 80. From 320 to 400, it increases by 80. So it increases by 80 square feet. What if the length of the pool was 16 feet? Oh my goodness. Okay, well, it's 16 feet instead of 8. So what would that do? It would, what do you think? You're right, it would double because from 8 to 16 is just doubling, so they would all double. All right. Says look for a pattern. If the length of each pool in the table were 20 feet and the widths changed from 5 to 6 to 7 to 8, describe the pattern. So hopefully you would be able to make a table, right, like this, okay? And it's saying if the length of each pool table was 20, so it's going to stay at 20. The width changes from 5 to 6. That's increasing by 1. Then you would go on to the next one from 6 to 7. So it's going to increase by 20 feet, or from 100 to 120 to 140 to 160. Okay? So this would be 20 times 5, 20 times 6, 20 times 7, 20 times 8. So it would be increasing by 20. Okay. All right, so this next one on page 666, you are going to notice that Jacob has a rectangular garden. So a rectangular garden means that not all the sides are the same. So let me draw a rectangular garden here. Find a rectangle, maybe. My computer is super slow. Here's a rectangle. Okay, so there's my rectangular garden. Okay, so what we're going to do is we have a rectangular garden. Hopefully you're drawing it. We know that it is a total of 56 square feet the whole way around, okay? So the whole inside on the ground is 56. The length of the garden, so the length right here is 8. It says, what is the width of the garden? So we don't know what this is. But we know that area equals length times width. So area equals the length, which is 8, times something, say A, equals 56. So you have to know your multiplication facts. So what did you come up with? You are correct. It's 7. Perfect. All right, I think I can come back. We have room. All right, a diagram of Paula's room is at the right. Her bedroom is in the shape of a rectangle. Here's the rectangle. Write the measurements for the other sides. What is the perimeter of the room? Perimeter means the distance around, okay? So if we know that this side and this side are equivalent, we would know this was 17. And if we know in a rectangle this side and this side are equivalent, this would be 12 feet. So it says, what is the perimeter of the room? If you add up 17 plus 12 plus 17 plus 12, you should get, hopefully you're doing the math. You are right. You should have 58 feet for your distance around. All right, Elizabeth built a sandbox that is 4 feet long and 4 feet wide. So it's a 4 feet this way, 4 feet this way. So all of a sudden you should know what shape that is. Okay, you're right, that is a square. She also built a flower box that is 4 feet long and 6 feet wide, and a vegetable garden that is 4 feet long and 8 feet wide. How do the areas change? Okay, well let's do 4 times 4, and we get, everybody got 16 written down? Okay, so now She said it was 4 times 6. And you'll notice I'm putting them right underneath each other because I want to compare the answers. So the flower box was 4 times 6, and the area would be, you are correct, 24. Well, then the last one was 4 times 8, and you'll notice I'm keeping the 4 the same. It's the front number because the second number is changing. So 4 times 8 is, you are correct, 32. If I am super organized, then I look at those numbers and I can see the change. So I put my little arrows like I always do when I'm doing math and I'm looking for a pattern. No shortcuts yet. We're still learning how to do this. So we have from 16 to 24, you are correct, it's 8. And then from 24 to 32, you are correct, it's 8. So how do the areas change? They increase by 8 square feet. Okay, and you should be able to see that just by writing down the math problems. Okay, find the pattern and complete the chart. So the total is 50, then it goes to 60, then it goes to 70, then it goes to 80. So there's a pattern. So you should see, okay, well, I'm skip counting by 10. So then I go to the length and it goes 10, 10. Well, then I would go 10, 10, 10 because there's a pattern there in the length. Then we go to the width and it says 5, 6, 7, 8, 9. Okay. How can you use the chart to find the length and width of a figure with an area of 100 square feet? Okay, so maybe you could extend out, okay, because the total area here goes to 90. So if you extend this out, what do you think? So we have 50, 60, 70, 80, 90. There would be 100. Okay. We're looking for 100 square feet. Well, we got our 100, 10, 10, 10, 10, 10. So this would be 10. 5, 6, 7, 8, 9, 10. And we know 10 times 10 is 100. Okay, so turn the page. We are on your practice and homework, and it says problem solving, area of rectangles. So you guys are going to pause the video and you are going to answer all these questions, okay? And I want you to be able to try to do it on your own without me helping you, okay? Because I can't believe this, but in 5, 6, 7, 8 days, you are going to be fourth graders. And so you need to be able to think always on your own and to be able to make good decisions and to find keywords, underline them, find the patterns, take your time, show your work, okay? Everything that you've learned is in third grade. Okay, so pause the video and get started. Okay, so these were kind of fun to do because the patterns were pretty simple. So if you looked at the first group, okay, you saw that it was 2, then 4, and then hopefully you got, so you had the 2, oh, my pencil's not, 4, then you got your 8, and then did you guys skip count 2, 4, 6, 8, 10, 12, 14, 16? How many of you didn't even have to count those? You could see them because the first box, A, it doubled. And then B, you could double B. You could put 2 B's on top of C, and then put 2 C's on top of D. So it went from 2 to 4 to 6 to 8. I love when you can see patterns like that. It makes life so simple. All right, so you could see that the width doubled and the length stayed the same. And then the areas doubled of all of them. It went from 2 to 4 to 8 to 16, which was really cool. Super simple to see too. All right, so Lauren drew the designs below. Each square unit is 1 square unit. Okay, it's 1 square centimeter. If the pattern continues, what will be the area of the fourth? So you could see I put 3, Then you could see there were 2 groups of 3, so that means 6. Then you could see the 3 groups of 3, which would be 9. And then if I had 4 groups of 3, it would be, you are correct, it would be 12 square centimeters. I can't believe the change in the weather. Did you notice how it was sunny like when we started the video and now it looks like it's going to rain? Western PA weather changes quick. All right, so Henry built one garden. One was 3 feet by 3 feet, which was 9. Then he also built one that was 3 feet by 6 feet, which was 18. And he built a third one, which was 3 feet by 9 feet, which was 27. All of the widths were all 3, but you could see they went up by 3, 6, 9. And so we know that when you go up, you're actually skip counting. The increase was by 9, which was a multiplication. You could see it. You could just multiply each one, which was cool. All right, so this one, Joe, Jim, and Jack, they have 27 football cards. Okay, they have 27 football cards all put together. They want to know how many cards does each boy get if you equally divide them among those 3 kids. So there's 27 total. So you take the whole and you equally divide it among the 3 boys, and they would each get 9 cards. Nita uses 1/3 of cartons of 12 eggs. So we know that there were 12 eggs in the whole. So I broke it up into 3 equal groups because the denominator right here told me how many equal groups, and this was how many of those equal groups she used. She used 1 of the 3. And so if you have 1/3 of 12, well, there's a third, there's a third, and there's a third. Well, in each third, there was 1, 2, 3, 4 eggs. So how many eggs did she use? She used 4 eggs. And we did a lot of that. That was a lot of fun. I remember when we did that together. All right, Brenda made 8 necklaces. So she's got 8 necklaces. 1, 2, 3, 4, 5, 6, 7, 8 necklaces. On each necklace, there's 10 beads on each necklace, okay? So how many large beads does she use? She uses 80. And then Neil is tilling, or he's he's not tilling the kitchen floor, he would be tiling it. Each square tile is 1 square foot. Neil uses 6 rows, and every single row has 9 tiles. So right there, you know it's multiplication. Plus its area. So what is the area of the floor? It's 54 square tiles. All right, well, I hope you guys had a wonderful math lesson. Looks like since it's raining out, I might do another math lesson just because, hey, it's a rainy Friday. I hope you guys have a great day. Take care, and I'll see you next week.